Hello, dear authors and invited guests. Welcome to the technical session 1B. Very good afternoon. And it is my great pleasure to welcome you to the 5th International Conference on Information and Communication Technology for Intelligent Systems through Zoom on behalf of ICTIS and Global Knowledge Foundation. We are thankful to everyone present on this platform to go along with us digitally for the conference in this unpredictable circumstances of COVID-19 and making this conference more productive. Also, we wish everyone and their families a protected time, and we all will get together past this soon. We hope you will enjoy 2 days of the knowledgeful and interactive sessions. So just before we get started, I would like to introduce you all to the chair of this session, Dr. Navneet Sharma. He is associate professor at Department of Computer Science and IT, IIS University. He has overall like more than 18 years of experience, and areas of his interests include web application, cloud computing, DBMS, EDP, database designing, big data, data science. So, okay. Now, thank you so much, sir, chairing the session.
Thank you, ma'am. Thanks for inviting me for this session. Thank you so much.
Now, I would like to start with papers. Also, there is a special note for presenters. You will be given 8 minutes for the presentation. On 7 minutes, we will raise a gentle reminder, and I request while the presentation is going on, other participants muted. So our first presentation is from Ms. Ujjwala A. Kshirsagar. Her paper is about low-cost health monitoring pedometer using IoT. Ma'am, over to you. You can start your presentation.
Yeah, thank you, madam. Let me to share the screen. Is this screen is visible to all of you?
Yes, ma'am.
Okay. Hello, everyone. I am Dr. Ujjwala Anil Kshirsagar, presenting a paper on low-cost health monitoring pedometer using IoT. I am the associate professor at Symbiosis Institute of Technology and presenting a paper in 5th International Conference on Information and Communication Technology for research for intelligent system. Now, pedometer was initially used by fans of sports and exercise, but nowadays, as a physical activity measure, it is becoming popular. This paper discusses the idea of pedometer as a part of holistic approach designed for the modern healthy lifestyle through regular physical activity. A paper deals with a design and the measurement of different parameters using electromechanical pedometer, which can measure the steps in meter on a dial or a counter. IoT-based pedometer using Raspberry Pi is proposed as a product in this paper. This paper focuses a system, a fitness tracker system that tracks all the motions and physical parameters with the aids of different sensors. It links all the sensors data and display it to a related metrics such as steps count, then distance covered, calories burned, heartbeat ratio, temperature of a body, height and weight on a single platform. Let's have a look on the architecture of a IoT-based pedometer. This IoT-based pedometer uses a Raspberry Pi. Here the Raspberry Pi acts as an server. When the server is linked through the internet, it can share the data from the Raspberry Pi. Now the data saved in the Raspberry Pi is nothing but the data which we have collected from the different sensors. For this IoT-based pedometer, we have used the 4 sensors. One is the temperature and the humidity sensor. 2, we have used a step sensor for the each of which acts as a limit switch and being fitted in the shoes of a physical person. And also we are having a heartbeat sensor. All the data from the Raspberry Pi is being get interlinked through the cloud to the mobile, where we have used a MIT app through which we are getting all the parameters. There are the 2 display module here. One is nothing but a LCD display, and the second one is nothing but the display from the mobile. Now, how we are getting the data, that we will see in the further slides. Now, this shows the flowchart of a IoT-based pedometer. Now, first of all, the pedometer should be operated with a power bank to provide the power. Then, first of all, before the start, we have to initialize the count equals to 0, because we have set the final value of the count to 100. Then to start the measurement of a body temperature and to check the status of the other switches, initially we have to consider all the switches have been reset in a reset position. And once all the conditions are cleared, then after we will start the measurement of footsteps, calories burned, and the distance covered during the activity. Every time the increment is made a count 1, and when the count reaches to 100, then the data will be get automatically displayed on the mobile app. Now here you will find out, this is nothing but the actual working prototype of a pedometer. Here, this is nothing but the Raspberry Pi. Raspberry Pi is nothing but it's a very compact and low cost. It serves as a server, and when it linked through the internet, then the data through the Raspberry Pi is being shared to the mobile or any display device automatically. There are the 2 display unit here. One is the LCD, 16-bit LCD display, and second one is the mobile display, at which we have shared the MIT app, where you will get all the parameters related to the pedometer. Now the sensors are here. This is a heartbeat sensor, and this is a control circuit for this heartbeat sensor. This is the temperature and the humidity sensor, and these 2 are nothing but a steps sensor. Now on the MIT app, the parameters which we have set are nothing but a step count, then distance covered, then calories burned, then temperature, then heartbeat rate, height, and the weight. Here we will find out that before initiating the process for the measurement of a parameter, first of all, we have to enter the weight and the height. Here, for example, I have entered the weight 70 kg and the height 161. These are the results which are being experimented on me. And before the measurement, first of all, we have to reset all the values towards 0. Now, after that, on the LCD, we will get the temperature and the humidity reading. And also here you will find out that once the temperature and humidity already is being there, here on the LCD screen, we have seen beats per minute, which is being counted as a 85. and the distance covered is being counted as a 42.67 meter, where the number of steps nothing but a 70.
Sorry to
And
interrupt you, ma'am, but you have 1 minute left.
hello.
You have
Hi.
1 minute left.
Yes, sir. Yes, sir. And the total calories burned are nothing but 2.03. And these are the readings which we got on the app. That is a distance covered 42, then calories burned 2 calories, temperature 28, then heartbeats are 85 beats per minute, height 161 centimeter, and the weight 70. Now here in short, we will see how the calories are being get calculated. For this, we have developed a coding with a Python, and we have entered the data into that, and with that data, here, first of all, we have calculated the calories burned in meter, which is being equals to 0.57 multiplied by 154 divided by 1609. It is a standard count, and which is equals to 0.054. And therefore, the total calories burned equals to the calories per meter multiplied by the steps. So here you will find out that it is equals to 0.54 multiplied by 42, that is the distance covered, and that goes to about 2.2 calories. These are the results which we got. Exactly, we get the same result which we have calculated. Now the conclusion. In this paper, we implemented a pedometer for health monitoring. The novelty of the pedometer is that the digital display offers steps covered and distance covered, calories burned, heartbeat ratio, temperature of a body, height and weight are brought on a single platform with IoT. This technology is used to easily monitor the health of athletes, senior citizens, and ordinary human, which tracking and calculating the calories burned and the heartbeat rate with a Python coding with a mathematical formula. We use a Python coding. We successfully developed an Android application in the health domain using the concept of a Raspberry Pi and the IoT device. These are the references which I have used.
One question from my side.
Thank you.
You have presented a very nice topic and implemented a nice device also. So, which IoT device you are using? Can you subscribe on?
Yeah, it's a Raspberry Pi, sir.
And what is the approximate cost?
Sir, its approximate cost is only 1,600.
The other devices which are available in the market?
Yeah, sensors are very cheaper, just having a cost of 20 from rupees 20 up to the rupees 160. Therefore, we just mentioned it's a low cost because whatever the apps are available on the mobile phone, these are too much costly, and even the devices are also very costly, costing near about 30 to 40,000. But within 3,000, we have developed this IoT-based pedometer.
What patent this?
No, sir, we have not patented, but I think we should patent it.
Okay, madam, I have one question. How you measure your results? How you compare your result accuracy?
Yes, sir. Actually, by the standard formula and with the algorithm which are being available, on that basis, manually we have calculated the value of the calories burned. And also we have calculated with the same parameter, we have observed the observations obtained on the mobile application. The both are being same, means it indicates that the accuracy is more, because actually the calculated values are 2.02, and the same we are getting exactly on the app through the Python coding.
Okay, so you have not mentioned the recent paper. Have you reference?
Yes, sir. Yes, sir. I have
Uh, which paper
referred.
you have recent paper?
2018, 2012, 1 minute. Uh, this 2018, sir. 2, 3 papers are there.
Okay, so yes,
Design
yes.
of network. Yeah.
I'm asking because I have not seen the latest paper in your reference. 18 is the last one, so 21 is going on. So there will be a
Yes,
paper
sir.
in between these 2 years.
Yeah, in the revision, I have added that.
So you are saying there is no some results in this area from last 3 years.
Actually, I have searched, sir, but related to the pedometer, I got this one. After that, I have not searched for this year.
So my suggestion is to just search more papers on this area and compare your results. What they have proposed, what they have used some techniques, and compare your results with them, and then
Yes, sir.
yes, you can explain your paper in proper. Okay,
Right, right. Yeah.
okay, thank you.
Thank you so much, ma'am.
Thank you.
Okay,
Thank you.
before starting ahead with another presentation, I would like to introduce our another session chair, Dr. Deepak Mane. He is an associate professor in Department of Computer Engineering, JSPM's Rajashri Shahu College of Engineering. He does research in deep learning work. So thank you for chairing this session.
Okay, well, thank you.
Yes, sir. And now our next presentation is from Pavni Parghi. Her paper is about innovative approach to onboard media forensic of a drone. Hi, Pavni, are you there?
Hello.
Hi, Pavni, over to you. You can start your presentation.
Okay. First, let me share my screen. Is my screen visible?
Yes, yes.
Okay. Good afternoon, everyone. I am Pamni Parki. I am student of National Forensic Science University and currently pursuing my digital forensics and information security. I am here to present my research, innovative approach to onboard media forensics of a drone. And my co-authors are Rishi Dhamija and Wing Commander Animesh Kumar Agrawal. I would like to start by throwing light on the motivation behind this research. As we all know, today technology is constantly evolving in every domain. The newest domain it is unnamed aerial vehicle, often known as drones. And recent crimes and being used in military and civil world proliferation, drone has given rise to a lot of security issues. And now it has reached a stage where use of drone by an adversary become a threat for civil and military aviations. Increasing incidents of drone and recent attack on Saudi Aramco prompted me to conduct a study on drone forensics. To counter these challenges, it is very much essential to develop a forensics expertise to answer some generic questions like how incident occurred, why, when, what was the purpose for this crime, and other related questions to the attack. After preliminary study, it is emerged that drone forensics is a very huge domain, and one of the most important components which carries wealth of information is storage media associated with the drones. because it consists of valuable information that will be helpful to forensic investigator. Effective analysis of storage media would answer most of the questions led to security of and sources of any drone. Here, this research focuses on a methodology of forensics on any storage devices that any drone would use. So, for a better understanding of the domain, I have read and referred to a lot of articles and research papers. One of them was forensics analysis of popular UAV system. In this, authors have covered the use of open source tools and have developed scripts to conduct forensics of a drone. Here, in this research, only analysis of flight logs was considered, but other aspects like storage media devices and mobile platform were not in consideration. Another research which we referred was Gryphon, drone forensics in data flash and telemetry logs. During the course for this research, a tool was developed to collect information about data flash and telemetry logs. This tool was capable, this tool was capable to also analyze data flash and telemetry logs. But the limitation was an effective forensics methodology was not followed while investigating a drone incident. This research is focusing on the analysis of commercial drone coming from a manufacturer with the second highest stakeholder in drone market after DJI. The drone is a unique Typhoon drone. This drone was chosen as there are recent incident where this drone was used. This drone was used for illegal delivery of drugs in a prison. The aim was to extract maximum evidence from the storage of the drone and analyze it so that it can be presented as a useful forensics evidence. The image of the drone is analyzed using 3 different forensics open source tools. To achieve this aim, first step towards methodology was to gather information about various drones available and which drone is getting more used worldwide and which drone was recently used in any kind of drone attack. After preliminary study of forensics analysis of storage media would be in order to find various artifacts like serial number, MAC address, attached payload, photos and videos, and other relevant artifacts. Open source tools would be used for the analysis to maintain the data integrity at all the time. And at last, a detailed report highlighting the evidence gathered would be a part as the last step. For this forensics analysis, autopsy, hex editor, FTK imager were used as the tools. Now, following few slides consist the result of forensics analysis, user credential. The operator who was operating the drone, the ID of the operator was found while investigating the drone file, serial number. By using this evidence, we can know that if the drone was registered or not. So by this, we can find the culprit very easily. File system of the controller was found out to be FAT32. Let long coordinates of the recent flight activities of drone was also discovered. Now moving to the summary of the artifacts that were found from different forensics tools. Autopsy was able to find almost all the artifacts while FTK imager and HXD was found the other artifacts that autopsy was not able to find. To conclude this research, it brings out the methodology to carry out forensics of the onboard storage media of a drone, as it will be very helpful to find the culprit and for a punitive extent. 3 open source tools have been used to compare the results of the recovered artifacts. This tool has given a raw information like file system, telemetry information, timestamp, camera details, route flown, database details, and others. However, there are still some points left to be need to be addressed to complete the entire storage device forensics and to complete the drone forensics puzzle. Manual search techniques needs to be adopted to gather more artifacts and then automate the process to decrypt proprietary format. Light path reconstruction can be a part of future work. Here are some references that I have referred for my research. Thank you. Any questions?
Is any question from the audience?
Sir, your voice is not audible.
Any question from the audience? Anybody wants to ask something?
Okay, Manish, can you once again can you tell me what you have did, because I don't understand.
Sir,
You were
I can't listen properly. Can you?
Sir, your voice is not audible.
hello.
Yes, now it is audible.
So can you repeat what you have did as some novelty, what you did and how you compare your results, because I didn't get what you are saying properly. Can you repeat once again as a summary part, conclusion part?
Yeah, yeah. So drone carries storage devices on it. So storage device will consist a lot of information like photos that drone have captured, coordinates, file system, and other relevant artifacts. So whenever a crime related to drone will occur, storage media will be a fruitful point to find artifacts. As if we found any storage devices of a drone, we can investigate it and we can found artifacts from it. So by, as I have mentioned, I have found serial number. So by serial number we can know this, okay, this drone was registered and this is the operator. So by analysis of storage devices we'll find tons of artifacts which would be helpful to solve drone related crimes, as drone related crimes are increasing day by day and new security point will be drone only. So I have analyzed storage devices to carry out to find relevant artifacts and to propose the methodology that it can be used in drone related crimes.
Okay, so you are saying by using the registration ID we can find out the proper drone, and you are proposing something for what? You are proposing analysis technique for what?
For forensics analysis of onboard storage devices, if you found any storage devices related to drone, what to do that and what tools will be beneficial to find what kind of artifacts.
Okay, so just you are proposing the some methodology for the purpose of analysis. Yeah, is it clear?
Yes, sir.
Okay, so I have did some testing for you are proposing something. Have you implement, or how you are saying whatever you are proposing it is better for that forensic?
It is, I'm not saying that it is better, but it will be a start point to start forensics of storage devices, as we don't have any guidelines to conduct a drone forensics as of now. There are methodology or there are guidelines to conduct forensics of mobile devices or and something else, but there are not particular guidelines available for drone forensics. So I'm just suggesting a methodology that by using open source tools and by comparing them, we can validate the artifacts that we have found. I'm just suggesting a new way to conduct forensics of onboard storage devices.
So
Sorry?
Sir, you are on mute.
okay, what are the different proposing techniques you are proposing? Can you tell me the some technique name, method names, or tell me some details about that analysis method, so it will be the helpful for that department?
Yeah, whenever you will find a storage devices, first try to look for visible artifacts, then image it using forensics tools, and then analyze on a copy of the devices in commercially available tool or on open source tools that are validate in law of code. This is my methodology.
Okay, okay, fine, thank you. Good.
Okay.
Thank you so much, Pavni. Our next presentation is from Anton Chabert. I'm sorry if I mistake pronunciation. His paper is about manufacturing information systems for forestry companies based on integrated modular a modular approach. Many companies one tool. Hi, Anton.
Hello. Um, can you hear me?
Yes, yes.
Okay. Can you see the screen of my presentation?
Yes, it is visible.
Okay, so let me start. The title of my presentation is already clear. The paper ID is 483. Large forestry enterprises with a diversified production include a large number of interconnected end-to-end processes of wood utilization. Effective management of such processes is not possible without modern manufacturing information systems, which allow to jointly consider multiple key influencing factors. The design and development of manufacturing information systems must take into account requirements of customers, which are forestry companies, and suppliers, which are IT companies. Despite the conflict of some of their requirements, it is important for both parties to reduce the spent time and money. Thus, there is a need to develop a methodology for creating MIS for interconnected end-to-end production of forestry enterprises to reduce development cost and maintenance cost, simultaneously with improving their quality. Analysis of software for forestry enterprises reveals a large number of foreign and Russian IT systems. Some of them are presented on this slide. Among the multiple subsystems and functions of a corporate MIS, production and sales planning and management subsystems stand out because their effective implementation necessitates to accurately take into account specific features of complex technological processes. They require much attention. Production planning and sales management systems mainly import data from the customers' accounting systems and from the production equipment, but also many parameters are entered manually. The resulting production plans are transferred to relevant departments of the enterprise and to the top management. Such systems must use adequate and accurate mathematical models. When choosing a design method, the typical design solution is preferred, which consists in developing and using typical solutions that include basic elements which are grouped into subsystems and then into typical industry projects. In practice, a mixed approach is used in which typical industry projects are customized within a project delivery. On this slide are the main blocks of the methodology of designing MIS for forestry enterprises. First, we select the appropriate typical system. Define the production chart, including resources, semi-finished and finished goods. Select appropriate unified procedures. Define constraints, control variables, control parameters, performance criteria. Compile the mathematical model by consistently applying the unified procedures. Customize the user interface and update the library of standard components based on the project delivery experience. Thus, specifics of each enterprise and its equipment is taken into account. Using this methodology, we have developed a suite of software production planning systems for various forestry enterprises. In particular, Opti sawmill system improves the yield of sawn timber and utilization rate of equipment, with average monthly production capacity of 25 to 35,000 cubic meters of lumber, the economic benefits amount to $500,000 to $1 million annually. Similar effects are provided by opti-corrugated system for corrugated board producers. Opti-loading web service is used for optimizing shipment of paper, sawn lumber, and other goods. The suite of systems is based on complicated architecture that includes desktop solutions and cloud-based services that inherit same business logic, user interface, and database management components. This suite of systems covers the main production processes from forest management to and logging to production and shipment of finished goods. The systems are in use at multiple forestry companies in Russia and abroad. More information and demo versions of developed systems is available at the website. To conclude my presentation, I would like to note that further research and development is required to further elaborate models, algorithms, user interface components, and other components which are the building blocks for the systems. This completes my presentation, so please ask questions.
Thank
Any
you, Anton.
questions, sir?
Yeah. Am I audible to all of you? Yeah, Anton. Are you getting
Sir,
my
your
voice?
voice is not audible.
Now it's clear?
Yes, yes.
Okay. So, Anton, there is one question. You have presented your presentation very nicely, especially the comparative analysis on the third and fourth slide. Okay. So, yes. Back.
Okay, this is slide 1, 2, 3, third and fourth.
Move next. Yes. And next. Okay. So it's fine. You have compared all the marketing system and the analysis of your systems. So what is your conclusion towards this analysis?
Our conclusion is that the main focus of our research is scheduling, production scheduling, operational control and management, and sales management. The cornerstone for production and sales planning is the detailed mathematical model of the production technology.
So, any question from the audience? Deepak sir?
Okay, next slide, please. Okay, so tell me how all these steps are useful to take a better decision.
The production planning system imports data, initial data from accounting system and from the equipment. The management, the production departments, the sales departments, they provide their targets. How much goods must be produced and what are the expected prices of these goods. The supply department provides information about the raw materials supply and their prices. The planning system uses the mathematical model of the technology to provide the production plan. Normally it's a monthly time span, and then it is further elaborated into production schedule how the enterprise can produce the required amount of goods using available raw materials so that the sales of these produced goods yield the maximum profit. And this production schedule is provided to production units. The sales plan is provided to the sales department, and sometimes the feedback is given to supply department to ensure that required raw materials are provided for the production.
Okay, thank you.
Thank you.
Thank you so much, Anton. Now, our next presentation is from Pooja Krishan. Her presentation is about secure analysis of disaster area using satellite imagery and deep learning. Hello, ma'am. You can start now.
Yes, thank you so much. I'm just sharing my screen. Yeah, I hope my screen is visible and I'm audible as well. If not,
Yes,
please
yes.
let me know. Yeah,
Yes.
thank you. So yeah, good morning, good afternoon, or good evening, depending on wherever you're watching this from. Our paper is titled Secure Analysis of Disaster Area Using Satellite Imagery and Deep Learning. And I'm pursuing my bachelor's in computer science from Loyola UCAM College, affiliated to Anna University. Okay, it's not moving to the other slide. One sec. Yeah. So whenever natural disasters occur, we have to do two kinds of things. One is to detect the area where the disaster has occurred. And another thing that you have to do is prioritize areas which need immediate attention. So this is what we've strived to achieve in this paper. And in order to do this, we've used deep learning techniques as well as digital image processing techniques. So by so doing, we are able to allocate resources more efficiently, thereby saving time and money. So we surveyed around 20 papers, and the key findings in a few of the papers are presented to you now. One called Deep Cascade Learning by Enrique and his co-authors talked about how to train deep neural networks much more efficiently, since when you're using multiple deep layers in a bottom-up fashion. And then there was another research on how to analyze disaster areas based on Twitter links, based on tweets from people nearby tweeting about the disaster and how to improve recovery based on that. And another paper focuses on it's a case study which focuses on forest fires in a specific area, which analyzed images from Landsat 5 satellite. And since our paper is titled Secure Analysis of Disaster Area, we also had to include security algorithms to make the system more secure. And in order to do that, before doing that, we researched a few papers on how to make our crypto system more efficient as well. So moving on, our proposed architecture for the detection of disasters consists of two models. One is the convolutional neural network, and another is the VGGNet architecture, which is a type of convolutional neural network inspired from AlexNet's AlexNet model. So before we trained our model, since data sets were not available and it was not open source, we scraped the web to get satellite images of data, and we had to pre-process as well as augment the data so that training can be done efficiently, and as well as you can compensate for insufficient image data that we had. So we did both of that, and pre-processing also consists of, image augmentation also consisted of flipping and rotating the images and all of that. So coming back to the models that we've used, the convolutional neural network processes crops the input to a 64x64 width and height. And since we scrapped the web for satellite images, we have 3 channels, which is the RGB color coding, and the VGGNet crops the image to a 96 cross 96 width and height. And again, we are using the RGB image. And since we are passing our data through max pooling, convolutional 2D, and all of these deep layers, this is exactly why we chose these 2 networks, which are convolutional neural networks, since VGGNet is a kind of convolutional neural network as well, because these models are efficient, are one of the most efficient ones available when you're training image data, because it can reduce the number of trainable parameters available. So that's that. And moving on, before feeding the input into our system, and after and in the output layer, we've used the ELGAMIL crypto system to secure the image data being fed over the network. So ELGAMIL crypto system is out there. It's a common public key crypto system, which is based on discrete log method, where if you have a prime number, a primitive root belonging to a multiplicative group, and an integer, then you can encrypt content, but you'll not be able to decrypt it if you have only the prime number and the primitive root without the integer. So that's the crypto system that we've used. So that concludes the disaster detection part of our work. And moving on, we have to prioritize areas of maximum damage so that you can target relief operations to those areas. So over here, we use digital image processing techniques. And before doing this, as you can recall, I told you we had used RGB color coding for training of disaster detection. But over here, for image processing, we converted RGB images to grayscale before processing the images before and after the disaster detection in order to identify areas of maximum damage. So we've used 2 techniques here. One is mean squared error, which actually identifies the differences in both of the images, the original image prior to disaster and after, from the mean value. So M and N over here represent the number of pixels in the matrix, that is the rows into the columns, number of rows into columns for both the matrices. And I of ij and k of ij over here represents the ith row and the jth column, the value of the pixel in that. And so for each, when you calculate the mean square error, you can, given an image, you can identify the areas, in other words, the pixels where maximum difference is, and hence, once you've already detected that there's a disaster there, there's something quite not right there. So that was our logic when we worked this out. So that's the first technique. And the second technique that we've used is something called structural similarity index, which, as the name says, detects similarities between 2 images. So over here, that is to be more precise, the original image and the disaster affected image. So over here, mu x and mu y represents the mean of the mean intensity of the signal. Sigma x and sigma y obviously standard deviation, and C1 and C2 are arbitrary constants that are present so that the denominator does not become 0. So over here, if you see the first term divided by the third term contributes to the luminance, and the second term divided by the fourth contributes to contrast. And so if you would, structural similarity index is a function of luminance and contrast. So that's how you check if the images are similar. So if they're similar, then no worries, everything's great. But if it's not, then there's some serious issue in those areas, and they have to be targeted to perform rescue operations. So that was the logic. And so going back to the disaster detection part, we have the 2 models that is presented right here, the ConNet and the VGGNet. So from the graph as well as the table, it's pretty obvious that the training loss and validation loss for the convolutional neural network is much lesser when you compare it to a VGG network. But in terms of accuracy, VGG network outperforms the CNN, and which is why we would choose it as a final model, since there's always a trade-off, right? And
sorry to interrupt you, ma'am, but last 1 minute left for your presentation.
Yeah, okay, I'll finish it. Thank you. So there's always a trade-off, right? So which is why we chose VGGNet, since we needed better accuracy. Also, the convolutional neural network performed faster as well than the VGGNet, but it was a trade-off that we had to make between accuracy and performance. So in conclusion, Yeah, so the work that we proposed is obviously an automated method to detect disasters without any manual intervention. And this work can also be included, can be extended by including sensors in order to infer better results. And like I said before, there's a trade-off between computational efficiency and security as well. And here uh, we chose computational efficiency and only stopped with the algorithmic crypto system. But if you want to reduce the key size of the algorithmic crypto system, since that's 1024 bits, it can be reduced to 160 bits if you combine the algorithmic crypto system with elliptic curve cryptography. So that is something which we could do if depending on the scope of your application, but we haven't done that here. And yeah, with that, those are my references, a few of the references that I've included in the PPT as well. And if there are any questions, I'd be happy to answer them.
Which data set you have used for your implementation purpose?
We haven't used any data sets. We scraped the web for satellite images of areas before and after disaster recovery, because there's not many good data sets which are available in Kaggle or open source uh, websites. So we scrape the web using Python code.
Okay, so how many output classes?
3. So there's a forest fire, flood, and earthquake.
Okay, so in your proposed architecture, you are saying deep neural network and VGC 16 is used, right? And I think
Yes.
both are existing model. Okay.
Yes.
So what your contribution, what you are added in your architecture? Because yes, you can say you can customize your architecture, but what is your contribution in that existing architecture?
We've made it more secure since we've like encrypted uh, the data when it's traveling through the network, but we didn't make any major changes to the architecture as such. So we were just comparing both of the architectures.
Okay, so you are not proposing, but you are measuring their performance, like as a CNN and VGNet.
Yes.
Okay, so how many samples you are considered for training, and how many samples you are considering for validation?
80-20, that's how we split it. So
Okay, when you are putting some results as a validation accuracy, so the samples are part of training, or these samples are not part of the training?
the samples are not part of, since we split our tests in like training and testing to 80 and 20, the 20 which is reserved for testing purposes is the one which is used for validation.
Because sometimes when we divide the data sets, normally 80-20, yes, 80-20s we are using, but in 80 itself we are putting some data for the validation testing, whether my training is going correctly or not, right? So for that we can say the validation testing. And actual testing means what? Which sample which are not part of our training. So my
Yes.
question is, when you are putting the result, these are my 67 for CNN and 92 for the VGG net. So my question is, the validation accuracy is part of training itself, or this testing is based on the train model?
Are you asking if we are performing k-fold validation or something like that? Because only then you would use training data for testing.
Yes. So have you
No,
used such
we haven't.
part of that cross-fold validation? Yes.
No, sir, we haven't. The training the testing data is separate. We don't mix both.
Okay, so last question from my side. In CNN, you are saying the sigmoid function, and in VGG architecture, you are saying there is a softmax. So yes, here. So
Yes.
how sigmoid activation function is useful for multi-classification? Because normally we are saying sigmoid function is generate the output in between 0 and 1.
0 to 1.
So
Yeah.
we can say this is a binary, two classes as the output. So in your system, three classes are at output layer. So how sigmoid function is useful there?
We also have a flattened layer, so that converts it to a one-dimensional vector, and from there, if you pass it through a ReLU function, then the maximum of that layer is outputted as the result value.
No, my question is related activation function. How sigmoid activation function? Okay, if you are answered, then you can say yes. Else, no. How this sigmoid activation function is useful for multi-classification?
Sigmoid activation function is not the it's not the output activation function. It's one of the activation functions while the network trains. In both the cases, we've used softmax activation function for the output. So
in both cases, you have used the software.
yeah, sigmoid. We've not now. Why I put it there was convolutional neural network. During training, we've used the architecture consists of sigmoid, but during the output there is a flatten as well. But VGGNet does not use sigmoid anywhere in its architecture. That's the. I just wanted to differentiate the training. That's why I've included it there. But output has softmax for in both the cases.
Okay, okay, it's okay. Good. Thank you.
Thank you.
Well, thank you, Ms. Pooja. Next, we have our presentation, Ms. Nirja Jain. Her paper is about blue filter in cloud storage for efficient data membership identification. Hello, ma'am.
Good afternoon to one and all present here.
Very good afternoon, Mr.
Should I start sharing my screen?
Yes, you may.
Is that visible?
Yes.
So the paper title is Bloom Filter in Cloud Storage for Efficient Data Membership Identification. I'm a research scholar from Bharat University, Chennai.
Ma'am, your voice is a little bit slow.
Hello, am I audible
Yes.
now?
Yes, yes, yes.
So my paper title is Bloom Filter in Cloud Storage for Efficient Data Membership Identification. And my paper ID is 650. So let us begin with understanding the motivation behind using the Bloom filters in the cloud technology. So cloud computing has been the buzzword since decades now, and the software industry is largely being affected with different types of architectural models that the cloud has flaunted to us. NIST has taken up a charge of defining cloud computing, even though there is not a final and formal definition of cloud computing till date. But still, NIST latest definition says that cloud computing is a model which is enabling ubiquitous, convenient, and on-demand network access to a shared pool of configurable computing resources. Now, these configurable resources might include network, servers, storages, applications, and different services. All these needs to be rapidly provisioned and it will be released as and when it is no more needed with the efforts taken from the cloud service provider. So the cloud model, which will be composing of 5 different characteristics and 3 different service models and 4 different deployment models. So these are the cloud computing models, infrastructure as a service, software as a service, and architecture as a service. So IaaS is responsible to provide virtual storage, virtual machines, that is VMs, virtual infrastructure, and some other hardware assets as part of the resources. Whereas SaaS will be responsible to compute the operating environment applications, which helps in managing the user interfaces as well. Whereas architecture as a service will be responsible to provide you or to cater to the needs of the different tenants to the virtual machines and operating systems applications and so on and so forth. So while moving ahead to the cloud computing characteristics, we have understood that cloud computing works on the basic characteristics of pay-as-you-go model. It has an ability to operate in heterogeneous environments. It also has an ability to encrypt the stored data so as the privacy of the data can be underlined and the security issues should be addressed. Cloud computing is in demand largely because of its self-servicing model. It also supports multi-tenancy, and scalability and elasticity are the best characteristics which are making cloud computing so very popular into the industry. Now, this is a cloud database architecture which is composed of the cloud services, the cloud infrastructure, cloud platform, and cloud storage. Now, whenever an organization is planning to shift its responsibility of saving and storing the data onto the third party, then this cloud service provider will obviously come into picture. There are some basic characteristic features or possibilities available with the cloud service, cloud storage, which is the object storage, file storage, and block storage. Object storage is the scalability, which is the basic characteristic feature of this object class. Now, Amazon S3, which has the scalability and flexibility characteristic feature attached to it, as well as it has an ability to import the existing data stores to analytics, backup, and archives. That is what the object storage is all about. The file storage is often supported with the NAS servers, and Amazon Elastic File System, that is EFS, is ideally suitable for large content data storage services. Then you have the block storage, which is based on the concept of direct attached storage or storage area network, that is DAS or SAN. So it is again highly demanded by dedicated ERP systems, and Amazon Elastic Block Storage also makes use of this block storage device, block storage feature. So there are multiple cloud service features that the Amazon offers. I can list a few like S3, Amazon Glacier, EFS, EBS, EC2 instance storage, storage gateway, Snowfall, CloudFront, and so on and so forth. Now, whenever you are talking about the cloud storage, you need to consider few important factors like client self-service, strong management capability, performance characteristics, appropriate block-based protocol, and seamless maintenance and upgrade. So whenever you are planning to successfully address the cloud service provider's capacity, it is expected that the system workload and the characteristics of the data storage requested need to be understood thoroughly. So the goal of a capacity planner is to identify the critical resources that are needed and to keep adding more resources so that you can avoid the bottleneck dynamically. So scaling up either vertically or scaling out horizontally, it is a very critical decision, and it will eventually be affecting the cloud performance largely. So data storage need and the corresponding services which are available across all the cloud service providers keeps on changing. Like you do have a file system at Amazon, which is EFS, or you do have a structured data with the query. With Amazon, we use DynamoDB or Amazon RDS, or you use Amazon Cloud Search. If you have rapidly changing data, then you will be using Amazon DynamoDB for it. If you have to go for archival of the data, then you will be going for Amazon Glaciers. And if you are interested in dynamic website hosting, you obviously will be choosing either Amazon EC2 instances or Amazon RDS and so on and so forth. So the cloud storage data model is something which is basically unstructured, untrusted storage. There are chances that the data is highly vulnerable. It could be tampered by unauthorized sources. So such a data storage organization is primarily based onto the data flow architecture. So we have seen that Hadoop had been using such making use of this data flow architecture with the big data industry quite often now.
Sorry to interrupt you, ma'am. One last minute left for your presentation.
Yes. So cloud resource allocation process, which will determine the persistent system present system characteristics. It will measure the system resources demanded. It will determine the system with the overheads associated with it. It will predict the future And finally, coming to the mathematical model. So if we make use of the set theory, assuming that here S is the system, cloud data storage system, where I indicates the data storage index, C, the data storage capacity, E, the authority level, and the data node, B, the data available onto the data storage. So for every I that belongs to your system, we say that the index defined on the data storage is such that it can identify whether the data is available on the cloud storage or not. If the data is available, then on which data node the data can be located and what is the authority level defined for the data access. So we will be making use of the hash function out there. What a hash function is, it is a mathematical function which involves accepting an arbitrary length input value from the user, converting that input value into a fixed length compressed numerical value, and finally, coming to the problem definition, we actually are looking for a dynamic resource organization strategy wherein we will be putting more emphasis to this Bloom making use of the Bloom filters that will help us in identifying the association between the data that is being requested from the user side and the data that is lying at the storage side of the data nodes. So the Bloom filter, we do have different storages available at different data nodes, and Bloom filter will be responsible to check the data existence into the storage system. There is a probability of false positive in the Bloom filter as well, and that will be depicted using the given formula. So we are assuming that Q entries of P are still zero after all the elements of S are being passed into the Bloom filter. As you all know that how the Bloom filter works. It works on changing the bit from 0 to 1 and 1 to 0 based on to the mapping of the data being available into the system. We also be going ahead with the pre-processing methodology wherein the Bloom filter will be allowed to generate the data verification indices, and these will be further be used for actual mapping using the key value pairs. So this is a simulated result for resource discovery time complexity when we are using the Bloom filter to check the existence of the data through the data storage devices and without the Bloom filter. So we have managed the systems to effectively check for accommodating the newer data as per the indexing that is being done onto the available data. And the Bloom filter can be checked to test whether the data is stored into the data node or not. And since this is an efficient lookup mechanism and a very complex and compact hash data structure, so this can be effectively used into the cloud environment. So that's all from my side. Thank you so much for giving me an opportunity to present among you guys. Thank you so much. I'll stop sharing.
Any questions, sir?
Okay, so I think already there are many solutions for cloud storage. So what you are proposing and how you are saying whatever you are proposing is better than existing?
Well, there are multiple solutions that do exist to the storage there, but what is the underlying problem is that I do not understand beforehand at which data node my data will be more secured and more easily accessible. Now to do that, the best strategy that Hadoop has been implementing is using some indexing structures. So Hadoop has been doing this using the data flow architectures. And Bloom filters are the compact hash kind of functions wherein you do know some keywords. So usually a query comes to the storage with some keywords, and based on to the existence of these keywords into your data node storage, it becomes easier for you to reach to the particular data node. So
Okay.
Bloom filters will be a kind of indexing mechanism that makes me reach to the location that I'm looking for conveniently and with a supersonic speed, I would say.
Okay. Okay. Thank you.
Okay. Thank you so much.
Thank you, Ms. Nirja. Our next presenter is Ms. Shrivani P. Her presentation is about prediction and comparative analysis using ensemble classifier model on leafy vegetable growth rates in DWC and NFT smart hydroponic system.
Okay, good morning. I'll just share the screen. I hope all of you can see my screen. Good morning to everyone present over here. So I would like to explain you about my research work. It is a prediction and comparative analysis using ensemble classifier model. And I have implemented these models with the growth rates between a hydroponic system. So hydroponic system, there are different structures in hydroponic system.
Shrivani, can you please make this slide full screen?
Yeah, I have made it. Okay, is it visible now? Okay, I am working under, I am a research scholar and doing my PhD in the computer science engineering department with the IoT and artificial intelligence under the guidance of Dr. Yamuna Devi from Ambedkar College. So today's agenda of my presentation is about the instruction, the different structures and what technology can be embedded with the hydroponics and the different existing systems and what materials and methods that I have used to build the plant growth and the methodology, the machine learning models or IoT technology that I have implemented, the results and the discussion. So the abstract of my project is I am going to compare a different leafy green species. In that I have chosen spinach as a green species, and I am comparing the better growth rate between deep water culture system and nutrient film technique, and which is grown indoors in a controlled environment system. So with the technology embedding like Internet of Things, so real-time monitoring of plant growth can be done, and different sensors can be implemented to collect the real-time data of the plant growth. So apart from that, several machine learning models can also be implemented to make a necessary decision making. So during the plant growth, when the things are not really correct, and also to predict the plant growth, such intelligent models can also be done. So the target thing that I have used for plant growth is height and number of leaves with the spinach plant. So the growth prediction model is implemented using ensemble classifier model. So what is hydroponic? Hydroponic is basically growing plants in nutrient rich water without soil. And here it is very safe, secure, and with efficient utilization of water and resources, the plants can be grown. So this is a very conventional way of growing the plants with respect to hydroponics. But when the technology is embedded in a controlled environment where the plants are grown at the indoors, so you can have a year long year around crop, and also any type of crop, not only seasonal crop, any crop can be grown in that indoor environment by giving a precision system with the sustainable farming. So the technology that are embedded are Internet of Things, AI and machine learning models. So this is actually the structure of deep water culture and nutrient film technique. In deep water, the plants are completely submerged, the roots are completely submerged, and because of the submerge only, the roots will be getting the nutrients through which the plants are grown. But in nutrient film technique, there will be a recirculated water, that is the same water is recirculated. But in deep water culture, we are not going to change the water until from the germination, transplantation stage till the harvesting period. So in nutrient film technique, the highest oxygenation of plants can be given. So the technology that can be embedded in this topic that I have done is we have implemented several sensors like LED sensors, sunlight, and I have used white LED lights in order to know the better plant growth. In my previous research work, I have used different LED lights, and apart from that, nutrient sensors like a pH, which measures the acidity and alkalinity, and otherwise I have used a nutrient solution sensor, which is going to measure the contents of nutrients, and the data that is collected from the sensor is uploaded to the cloud, and we have used pushingbox.com as such, and based on that data that we have received, the analysis of the growth can be done. So here if I go in general about the data analytics, we can use data analytics and intelligence models to optimize the resources for the plant growth in plant and disease analysis with respect to plants, flowers, leaves, and roots. And you also will be able to forecast the different parameters based on the climatic condition and set those parameters for optimal plant growth. And apart from that, analyzing the relations of different parameters and prediction of yields. So these are the different analytics that can be performed with respect to hydroponic plant growth. So when we come to the existing system, there are several models that have been implemented to find a better plant growth rate in nutrient film technique or any other technique. So here the one of the author has compared about NFT and soil based with spinach growth, and they have found that hydroponic system has given 87% better crop yield. And the same with the semi-automated NFT. Why it is semi-automated is only it's not completely automated, so that it can be able to intelligently not only monitor, it will be able to control when the things are not in the correct way. So here again the NFT system had given a better growth, and in the third existing system NFT, DWC and soil cultivation. So especially with resources, what are the main important resources that have been very problematic in all the countries. So here our intention is to reduce the resources that is being used in the hydroponic system. So in that, NFT has given a better yield with optimized resources. So in this project and research, I have created an indoor environment with both the system, that is deep water culture and NFT, and I have used real-time monitoring of nutrient solution, pH, air temperature, humidity, as well as nutrient solution temperatures, which are very much important for measuring the data of the census or plant growth. So apart from that, since the plants are grown at indoors, it has a lot of advantages, so that it will not be exposed to heavy sunlight, or it will not be exposed to the diseases, bugs, or any other insects. So I have used LED lights of 28 watts, which will imitate the sunlight for photosynthesis process, and it is only for 12:12 ratio, where 12 hours is given as a light, and the other 12 hours is given for the darkness. So in this methodology, in order to make the comparison of the plant growth, I have collected the data set from my system from the from transplantation stage till harvesting period. Since growth is between, for spinach plant, it takes only 35 to 40 days maximum for a complete plant growth. So I have taken only the smaller data set and ensemble classifier. So ensemble, by using ensemble classifier model, so if you are able to combine two or more models and then predict the crop yield or anything as such, the accuracy rate or the performance of the model would definitely improve. So in this, I have chosen two classifier models, that is naive-Bayes and support vector mission, and also to improve the performance, I have used
Sorry to interrupt you, ma'am, but one last minute for your presentation.
Okay, tenfold with the tenfold cross validation. So naive-Bayes and for both the classifier models, I have used binary classification. So based on the height of the plant, whether the growth has happened, if the height is above 0.5 centimeters, so the classification, binary classification would be set to 1. If the height is less than that, the binary classification would be set to 0. Okay, and here the performance of the model is evaluated basically through the accuracy rate. And apart from that accuracy rate, since it is a classifier models, we have used the receiver ROC AUC curve, which is in the range between 0 to 1. And here the accuracy, the rate of binary classification model performance rate is 0.6 and 0.4. And this first figure represents for DWC, and the second one represents the NFT system. So though it is very less, it is just because of the plant that I have chosen and the number of size of the data set that I have chosen. Maybe if the data set is larger, maybe the accuracy rate would also improve. And apart from that, the growth rate comparison is manually done by comparing the number of leaves, height in centimeters and number of leaves. And as per the observation that has been done, the NFT system had a really better growth compared to here. And you can also observe that initially there is a a better growth with the DWC system than NFT system, because it was due to the trial and experimentation that is done with the plant growth. There was the lights were off for almost 2 to 3 days just to see that whether there is a growth happening or not. So when the lights were off, there was no photosynthesis process, and hence the plant growth was very slow. So this is again the pH variation. Why the pH is considered? Because pH is the very important parameter that plays a role in the plant growth. If the pH is the spinach has a pH range of 5.5 to 6.5, that range is not exactly correct. If the range is not in that given specified value, then the plant growth definitely affect with the color of the leaves or the shade of the leaves, or it started falling apart. So that is this is the system that we have done it at home. Setup of the home system. The first part represents the
Sorry to
deep,
interrupt you, ma'am, but you have 1 minute left.
okay, deep water culture system, and the second one is NFT system, that where the pipes, the water will be recirculating continuously through the nutrient rich water. And then when I come to the conclusion, though the especially with the leafy vegetables, NFT system has better growth rate than DWC technique. And here I have compared only with respect to height and number of leaves, and we could have also done the same prediction with the different outcomes with fresh and dry weight. And I have also used a very small data set, just because the harvesting period of spinach is very small, and the model also can be implemented with the different leafy vegetables. These are the references that I have made, and thank you. If any questions, kindly let me know.
Shivani, nicely presented. Your comparison is wonderful.
Yes, sir.
Keep it up. Okay. So,
Thank you.
so from my side, if anybody wants to ask something, you may ask.
So, ma'am, you have used two technique, new bias and SBM, right?
Yes.
And you are proposing as a assemble model uh, for a plant. Okay, I suggest one suggestion from my side. You can also include some deep learning techniques, because
Okay.
I saw the some deep learning techniques are also useful for the same purpose. So
Yes,
you
sir.
can search more on that, and you can include these techniques for your further research.
Yes,
Good, ma'am.
sir. So thank you. And I have done that in using LSTM, sir, RNN based LSTM for my other research work. And it is already published in the journal. So that is with the deep learning model and large data set.
Okay, okay,
Okay.
okay.
Okay, thank you so much, Ms. Shrivani. Our next presenter is Ms. Rajeshwari Mattimani. Her paper is about pre-stamped monitoring and alarm system. Rajeshwari, I guess she is not here. So moving ahead with our next presenter, Ms. Jyoti Patil Devaji. Her paper is about performance analysis of the secure hash algorithm 2 and implementing on FPGA. She is also not available.
Both Rajeshwari ji and Jyoti are the co-authors for two papers.
Yes, sir. Both are not available. Never mind. So moving ahead with our closing remarks, I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already forwarded to the Springer. The publication will be live within 5 to 6 months. So kindly cooperate with the team of ICTIS 2021. I also thank our session chairs, Dr. Deepak Mane and Dr. Navneet Sharma for chairing the session. Token of appreciation to the chair on behalf of the team ICTIS 2021 and Global Knowledge Research Foundation. Thank you so much, sir, for your valuable presence.
Thank you, ma'am, for giving me the opportunity as work as a session chair. Thank you.
Okay, so I request to all to on the camera so we can take a quick snapshot of the virtual conference. Okay. Thank you very much. The room is open for 1 minute, like if anyone have any question answer. Stay safe, everyone.
So nice to see all the presenters in the session. They have presented very well and worked with the genuine presentations. Thank you all the participants, and thanks to GR Foundation.
Thank you very much, sir. So, ending this. Thank you, sir. Goodbye. Stay safe. Take care, everyone.
Bye. Good day.
Okay.